Hello and welcome back. We're going to continue our demos of Hyperledger Fabric. The best way to go through some of these demos is to work along with me while you're seeing this video. Try it yourself on IBM Cloud. I would encourage you to do that. So in the last lecture, we looked at how to set up your own network, create a channel, add peers, look at the blocks in your network and so on in your channel. In this one, we're going to look at a demo application.
This video is for developers working with Hyperledger Fabric, especially those who want to seamlessly deploy onto IBM Blockchain Platform. You'll see a demo of the new IBM Blockchain Platform extension for VS Code. It's open source and free for any developer to install from the marketplace. Right now, the extension is in beta, with new features being added rapidly. Our vision is for it to become the perfect developer tool to partner with IBM Blockchain Platform, which offers a suite of powerful operational tooling and plans suitable for anything from first project to multi-organization production network. Before we start, we should define a couple of key terms. Firstly, smart contract. Smart contracts determine what a given blockchain network does. Once instantiated, they define the way data is stored on the ledger, and they provide the transactions that can be used to interact with it, querying or updating it, for example. They are written by developers, packaged up, then deployed into a blockchain network. Unless you develop and deploy a smart contract, your blockchain network won't know whether to track the shipment of goods or help traders buy and sell valuable commodities. Secondly, client apps. Once you've deployed a smart contract and your blockchain network is ready for the inevitable storm of commodity trading, client apps are the ones that will call the transactions in the smart contract to interact with the ledger. They'll do so via REST APIs or client SDKs. We'll show a demo of the end result in this video, but for more detail on client app development, please read the accompanying blog linked in the description. The IBM Blockchain Platform extension can be found by searching for blockchain either in VS Code's built-in extensions panel or via the online VS Code marketplace. Once you've got it installed, the extension enables you to create a new skeleton project, develop a smart contract, package the smart contract, start a local Hyperledger Fabric runtime, and deploy the packaged smart contract for local dev and test. Now, over to our developer expert Rob for a demonstration of using the extension to develop a blockchain network for commodity trading.
We begin by creating a smart contract package using the command palette. The first thing to do is to edit the package.json, confirming the name of the smart contract and supplying a description. The next task is to edit the provided smart contract template and code up our 4 simple transaction examples. Note here that we require the Fabric Contract API package and that we are extending the contract class. Let's remove the template functions and start with a clean slate. First, the function which will be called when the smart contract is instantiated. In this example, it's just printing to the console. Let's create some basic data to set up the demo. We're using the put_state method to write data to the fabric. And as a commodity trading sample, we're creating a gold commodity, a wonder drug commodity, and 2 traders, solid investor and risky trader. The data is being written to the ledger, starts as JSON objects, and is then stringified. Let's now add a simple read function to check the quantity of a commodity that we hold. We're using the getState method available from the smart contract context to read the data, and then passing the output into a JSON object. The last of our 4 sample functions is the trade function, where we trade a commodity to a new owner. We get the data from the ledger, check it's valid, and then put it back with the new owner. That's it, our really simple smart contract is written. Let's save that. Going to the IBM Blockchain Platform extension via the icon, we will add a new package based on our project. We're now ready to deploy. We're going to be connecting to the local fabric for developer testing. We can toggle this into dev mode and then start it. Now the fabric is running, we can install our smart contract on the peer. and then instantiate it on the channel. The instantiate will take a few moments. Let's have a quick look at the client app used to submit transactions. The new Fabric Network module provides a higher level API to submit transactions using far less client code. There are 4 steps to get set up, then submitting a transaction is a simple one-line call to the smart contract. Developers who have worked with earlier versions of Fabric will really appreciate the single-line call to submit transactions. Here are the 4 setup steps. Step 1. Select an identity from the file system wallet. Step 2. Connect the gateway using the identity and a connection profile. Step 3. Get the network channel for the gateway. And Step 4. Get the smart contract from the network channel. Here are the single-line calls to submit transactions through the contract. Setup demo has no parameters. The test data is hard-coded into the transaction. Check quantity has a single parameter, and trade has 2 parameters, the commodity and the new owner. It's that simple. 4 setup steps, and then a single line to submit a transaction. The Fabric Network module is available in Hyperledger Fabric 1.4 beta and later versions. That's it. We have written a client program to exercise the smart contract. So let's look at the console output. We can see that the contract has been instantiated. The exercising program calls the demo setup, check quantity, and trade transactions.
We saw Rob create a new skeleton project, develop a smart contract, package the smart contract, start a local Hyperledger Fabric runtime, and deploy the packaged smart contract for local dev and test. Rob used a client app he developed to then submit some transactions to his blockchain network. We'll be working on features to support you in your own client app development in future releases of the extension. Talking of releases, at the time of writing we've already done 5, and very importantly, releases come with Conga comics, so check those release notes. Also, we're working on new features all the time to support the latest additions to the Fabric programming model. You can check out all the open issues and discuss them with the team on GitHub. So what are some of those latest additions to the Fabric programming model? Check the description of this video for a link to the accompanying blog where we'll tell you about developer features available in the Fabric version 1.4 beta.
Let's go and look at the code itself for what the smart contract looks like. Okay, so this is where IBM has made the code public. So this is the Marbles code. This is again gone through various iterations. It's fairly well written, and it's a good way for you to get a feel for what a smart contract looks like. So what is this actually going to do, right? So let's look at this. So we're going to be creating marbles. So each person can say, okay, I have a new marble, and add that to the network. So that's one operation. They can transfer the ownership of marbles between people. So if I own a marble, I can transfer that to somebody else, and in that same vein, I cannot change the ownership of the marbles that I do not own, right? If I don't own a marble, I can't change someone else's marble to be my own. So that will be prevented. So that will be an access control rule that we will implement. And there are some attributes to a marble. So that a marble has an ID, it has a color, there are multiple colors that are available. It has a size, small or large, and it has an owner. Right, so once a marble is created, each time it could change ownership across people, and all that will be tracked on blockchain. We are calling it marbles here, but you can think of any kind of an asset that is getting that's owned and the ownership can transfer amongst people. Right. So what does the architecture look like? So what we have is there is a marbles application. This application is written in Node.js. It has a client which uses the Node SDK that Fabric provides to connect to the smart contracts on blockchain. Right? So there is a smart contract deployed on each of the peers. This is the Marbles smart contract. We'll look at the smart contract also in just a little bit. What does the network look like? We have 2 peers. This is on the default channel. This is the ordering service, and there are 2 CAs for that each of the peers connect to. Right? So this CA, actually the peers don't connect to the CA directly. The CA is the one issuing identities, and you're going to use those identities, and the peer will validate those identities. And apart from the Node.js application, we also have a browser UI from which we can trigger transactions via the application onto blockchain. So there's a WebSocket connection between the browser and the Marbles Node.js application. And from the application to the peers, there is a gRPC, Google RPC connection that uses the Fabric SDK to communicate with blockchain. So that's the overall network architecture. So this tells you how to set up Marbles yourself. So this will be the next demo that we have, right? So if you, the IBM cloud makes it very simple for you. Just through a few clicks, you can experience all of this. But what does it take to actually do this yourself? So we are going to do this as the next demo. So hold your horses for that. It will take you through all the steps. That's right now in those 5 to 10 minutes, whatever is happening. We are going to do that step by step ourselves on a virtual machine that or any other system that you have. Okay, so this is how the Marbles will go through the application itself later. But let's look at a little bit of the code itself, right? So let's start with the smart contract code. So let me open up. So if you go to GitHub, there's a folder called Chain Code Source Marbles. So I'm going to open that in another tab. So let's go through the smart. So this piece of code that's in this folder is what is getting deployed as a smart contract on each of the peers on blockchain. Right, so this is part of your install and instantiate. So this is the smart contract code that's run in a decentralized fashion. So let's open marbles.go. Right, what does it provide? It first defines the data structures that we will be using. So we have a data structure called marble, right? It has an ID, it has a color, it has a size and an owner, right? Now the owner is actually a relation. It's actually of type owner relation. Now owner relation itself has an ID, username and company, but I think the owner object is a little more interesting. So it has the details about the object type. The main identifier is really this ID field. The rest of it is just cosmetic. Right, so there is a main function, but I think the two important functions to look at are init, and below that there is invoke. Right, what init does is the init function of a smart contract. So this is a required function that you need to implement in your smart contract. What the init function does is it initializes your smart contract with any parameters you need to set. Right, so you can set certain values as initialization in your smart contract. And this will get called at the time of instantiation of your chain code on a particular channel. So you've installed this chain code on a peer, and it's not at the level of a channel at this point. But then you instantiate that chain code for a particular channel, saying I want this copy of a chain code running on this channel. And then there's a separate state for that chain code for that channel, and you will be allowed to initialize that state. So what are we doing in this Marbles application? What are we initializing? So here we are going to take one argument, just for illustration of how that works. It's going to be a numeric argument, so you can actually parse this argument. You can send that as an argument to your chain code at the time of instantiation, and you can just check whether it's actually a numeric argument. So this gives you a way to validate any inputs provided to your network. So for instance, you can initialize your network with saying, okay, there are going to be 3 marbles that each of the members are going to own. So I'll create those marbles as part of initialization, for instance. You could do that, but we're not doing that here yet in this example. This just goes through that, and all it stores is just some key. This is again as an example of what you can do. So you can put state, you can add a new key and put some value to it. So you're just storing saying the UI is 4.0.1. Okay, so the initialization step just allows you to initialize, but let's look at the invoke, right? The invoke is what is going to get called each time your chain code is going to get, you're trying to perform a transaction or you're trying to query for some values stored in the chain code. Then it comes through the invoke function. So the peer will be calling this invoke function in the chain code, and that's how transactions execute. and everything within this invoke function, whatever is the execution, is going to run atomically, which means that any state you change here, either all of it will change or none of it will change. Right? So here, if you look at some of the functions that are implemented, so it implements a simple read and write, but you can do a delete marble, you can initialize a marble, you can set the owner for a particular marble, you can read everything. So tell me all the marbles across all the users, tell me everything. So that's another query. You can get history for a particular entity. So for a particular marble, tell me all the transactions that have happened for it, right? Maybe it changed ownership 5 times. Tell me all those transactions. So you can go get history as well. You can get marbles by range. So based on the name of the marble, whatever you've identified, you've given, give me all the marbles between this value and this value in the ID range. Right? So you can do that. Okay, so let's go look at some of these examples. So let's go back up a folder and let's look at writeledger.go. So this has all the functions that are modifying the state of the chain code itself. So these will be committed as transactions on blockchain when invoked. Okay, so let's take one example. I will come back to the delete marble, but let's go to init marble, right? So what init marble does is, as it says in the comments here, it's going to create a new marble with a certain set of parameters. So it takes a few parameters as inputs. So this is an arg string array. It expects 5 parameters. So that's, you can do a check on the number of parameters. And then what are those parameters, right? So it's doing a few checks here, saying the third argument must be a numeric string and so on. Then it's also checks whether the ID you've provided is actually unique. If it's not, then the marble already exists and you can't try and create a marble that already exists. So you're going to get an error there. So all these errors would result in the transaction itself throwing an error, and you will get that as part of a notification back from blockchain saying your transaction has failed, and you'll also get the error message along with it. Okay, so now all the checks have passed. So we're going to create a new marble. So you're going to set the doc type as marble. There's an ID, color, size, and owner. So you're going to set all of those things as provided in the user input. And you're going to call put state to store that information onto the ledger. So the put state is actually a call to the blockchain ledger, the state database. And you're going to store this key value pair. The key is the ID, and the value is the object representing the marble itself with all of these parameters. Right, so now once the put state is done, you've stored that on a blockchain. Remember, this is just the endorsement phase when this is executed. After this, all the nodes have to execute. It has to go through ordering service. It has to be validated, and only then will it get committed into the final state in blockchain. Right, so that's the process. You can also init owner. So this is creating a new possible owner in the blockchain. You can set owner for a particular marble. So what this will do is it does the initial sanity checks. It checks if the provided user, the new owner, is actually a valid user. So it does that. It gets the current state of the marble. It tries to find out who is the current owner. So it does a get state. So it goes and looks up the blockchain ledger to find out who owns this marble. Now check who is authorizing this, right? So is the person who invoked this transaction, is that person the owner of this marble? If they're not the owner, then you're not going to authorize them to transfer the marble that they do not own, right? So you have to own the marble you are trying to transfer. So unless you do that, this can't be done. So a word of caution here, this is just meant as a simple example, a toy example. It's actually possible for you to perform this check using cryptography, right? So you can actually send the credentials of the user or attributes of that user, and you can validate that it was indeed the owner of the marble is indeed the one trying to invoke this transaction. So this check, right now we're just doing it as a simple if condition based on the argument provided. but you can actually do this using cryptographic checks. It's possible to do that in chain code also, right? But we're not demonstrating that here. Okay, all the checks have passed. Now we're finally going to transfer the marble. So you're going to update the record, set the new owner as the owner provided, and you're going to update the argument, the same marble ID. You're going to put that back onto the ledger. So if this transaction goes through successfully across the network, the new owner would have changed, right? So there are other things about disable owner, delete marble, and so on. You can go through that at leisure. Right? So that gives you an overview of what the smart contract itself looks like. So it's a bunch of functions that are all manipulating state maintained by the smart contracts, by that smart contract itself. And the state is isolated for each channel. So you can have the same contract running on multiple channels, and they can be managing different state information. Okay, so let's go back to our GitHub and let's look up. We went through the chain codes. What are the other aspects of the application? So the other aspects are the application code themselves. So let's look at that briefly. So this all the application code is inside the utils directory, and there is a WebSocket server-side.js. So this is the server-side Node.js application that we talked about, and this is the one that's going to interface with the blockchain, use the client SDK, use the Node SDK to call blockchain to perform transactions. So what are some of the things it does? It gets the channel ID, it gets the peer URL. So all of these will be configuration parameters for the application. And if you want to create an marble, so this is data type is create, then what it would do is create an object, and it will call create a marble, right? It's part of the libraries folder. So you're going to create a marble with these parameters, and that create a marble will be calling the SDK functions. Likewise, you can also transfer a marble. It calls that, right? So this is the library function that I talked about. So this has functions for set marble owner, and it'll also have something for create marble also. Right. So the set owner is, if you look at it, it has the peer URLs, the channel ID, this particular chain code ID for this marbles chain code. All these are already set in earlier parts of the code, right? What endorsements you need, right? And finally, the chain code function to call. So it's going to call the set owner function. We saw this function previously in the writeLedger.go file. And it has the arguments that needs to be passed to the chain code. So it sends all of this information. It calls invoke chain code. So this is something in the SDK. So you go invoke the chain code with these parameters, and that will then call the blockchain. It'll send control to the peer to invoke this particular function on the chain code. Okay, so that was the server-side application. So apart from that, you can also have a UI. So we have a UI for this, and there is a UI building the JS, and it has the abilities that you will see. Some of these capabilities you'll see. You'll actually be able to easily drag and drop marbles as a way of transferring ownership. Right? So all those UI capabilities are also available as Node.js code. But that's all of this is now a step removed from blockchain itself. So I'll leave you to see these things at leisure. I would like to just prepare for the next demo. So far in the last two demos, we had it easy. We had the IBM Cloud do much of the work in the backend, and I just walked through what IBM Cloud is doing in the backend. So in the next demo, we're going to do it ourselves, right? So we're going to do everything from scratch, build a network ourselves. So for that, what I would encourage you to do is be prepared with Ubuntu VM. So that's what I'm going to use in the demo. But you can also use a Mac. It'll work just as well in a Mac. There are instructions out there where I'll show you the pointers for it. And there are a few prerequisites, so please install those prerequisites before you get to the next lecture. So you need Docker, Docker Compose, Node.js. So Docker and Docker Compose are how each entity of your network, the peers, the orderers, the chain codes, they're all going to be deployed as Docker containers. You need Node.js and NPM, so for some of the application development. You need a Git client and you need Golang. So please install these prerequisites before your next lecture, and next lecture we'll do it all from scratch, and you'll get a feel for what it looks like to run a network yourself. Okay, with that, thanks a lot, and I'll see you soon at the next lecture.